My name's Tabitha Lovett. I'm the General Manager of Philanthropy at Equity Trustees. Thank you very much for joining us tonight. This is the first public lecture that we've held for the Wicking Trust, and we consider it a great honour to be the trustees of the Wicking Trust and to be entrusted with the role of achieving their vision for what their trust was set up to achieve. John and Janet Wicking believed that ageing, Alzheimer's and vision impairment pose significant challenges, and they established their trust to explore and fund advances in treatment and care. Now, the trust was established in 2004 with their gift of $45 million. It's a significant bequest. It's now worth over $100 million, and it's distributed over $30 million in grants in the years that it's been operating. So it's a significant player in the Alzheimer's and ageing research sector. One of the things I particularly love about the story of the Wicking Trust is how often we're told about John and Janet's great love and regard for one another. Whenever we speak to their friends and their family who stay in touch with us, and who some of them are in the audience tonight, Liz and Peter Cooper, they always tell us about how they had shared values and they both had a genuine passion for philanthropy. During their lives, they gave a great deal to the community through their giving, and they volunteered with charities such as Vision Australia, which is one of the beneficiaries of their trust. Now, in terms of their backgrounds, John was a soldier and he volunteered during the Second World War with the Australian Imperial Forces. He served in Egypt and Crete, and he was captured by the Germans and kept as a prisoner of war. And I understand from his friends that that experience really profoundly affected him, and I think it formed his view of the world and what he believed was important. After he was liberated, he came home and he married Janet, who was his long-time love. And they moved to the ranges where they had a 2,000-acre cattle station, which they ran for 20 years. Janet's family owned the Kiwi Company, which started as a boot polish business. And you're probably all familiar with the logo of the Kiwi on the lid of the tin. In 1964, John, who was a very astute businessman, he was persuaded to leave the seclusion of their property and to take on the role of managing director and chairman of Kiwi International. And under his leadership, the Kiwi Company grew and was ultimately sold to Sara Lee in 1984, which I understand was a great outcome for the company. So John was regarded as a great moderniser in the Australian business sector, and he dedicated a large amount of his time to assist other companies through board appointments, and he served on a number of boards. He also served in a voluntary capacity on the board of Vision Australia for 18 years, 12 of which he was the chair. And in 1986, he was awarded an Order of Australia for services to the industry and community. Now, of course, if it had been today, probably Janet would have held a number of board appointments as well, because there seems to be agreement now that women do actually add quite a lot of value to companies and boards. No one seems to want us to fly planes, but we'll get there. Back at Equity Trustees, we have a portrait of each of John and Janet, and there's actually a request that they should always be hung together and never separated, which is a really lovely way to remember them. And the Friends of the Wickings always emphasise how you cannot speak of one without the other, because they were both warm and generous people who understood hardship and adversity, and as a result were active philanthropists. John's mother had vision problems, and that was an important cause to him. Janet was passionate about finding a cure for Alzheimer's disease. In the same way they were both ambitious to achieve change in their lifetime, we are ambitious in our goals for the Trust. We're proud to have long-standing and productive partnerships in place with Vision Australia and the O'Brien Foundation, two organisations with which the Wickings had close relationships. The Wicking Trust also runs a major grants program through which it is seeking to effect systemic change in the areas of Alzheimer's and ageing. And we're delighted that the Trust has been able to bring Professor Craig Ritchie, a leading researcher and thinker in dementia research, from the UK to Australia to speak to you tonight.
Our presenter tonight is Professor Craig Ritchie, who is the Professor of Psychiatry of Ageing at the University of Edinburgh. He's a world-leading authority in clinical trials in dementia and has been a senior investigator on more than 30 drug trials relating to dementia. when you get the opportunity to introduce someone like Craig, the temptation is to read his full biography and spend 15 minutes telling you about how wonderful he is and all his great achievements. Let me just say he is wonderful and he's had many great achievements. And there is obviously much, much more that I could say about him and his impressive track record. But I do expect that, like me, you'd rather hear from him than hear about him. So without further ado, please let me introduce Craig Ritchie.
So thank you very much, Grant, and a huge thank you to everybody at the Wicking Foundation for inviting me to give this apparently inaugural public lecture. It's one thing Grant didn't mention, and some folk in the room know this already, I've got a great fondness for Melbourne. I lived and worked here for 4 years. And I got married here to my Scottish wife, and my son was born up at St Vincent, so I'm very glad to be back. I haven't actually been back for several years. So the presentation I wanted to give tonight was essentially about a project called EPAD, the European Prevention of Alzheimer's Dementia Programme, which I'm fortunate enough to be leading over in Europe. But to get to that point of describing what the project is doing, and it's initiated already, but we're starting recruitment in April next year, one has to sort of lay out the foundation upon which EPAD is based. And to do that, I'm going to talk a little bit about the context for EPAD, the context for the P stands for prevention, some of those concepts which might go into a little bit of sort of statistical sort of descriptions and discussions of how we actually want to reconceptualize brain health, brain failure, and dementia. And then talk a little bit, and maybe come out through the process of the presentation, how we need consensus, because the project that I'm going to talk about is a partnership between 36 academic, commercial, SME groups in Europe and in the US. And it's only by pulling together that partnership we've been able to achieve, or hope to achieve, what we're seeking to do, which is going to be hopefully a fundamental shift in thinking about how we manage Alzheimer's disease. So we have a big problem. Okay. So, by the way, I don't show any p-values in this. I don't talk about data. There's no. It's all conceptual. I don't do the p-value. I do it, but not in presentations. So what we have, this big problem, is mediated by three factors in this formula. We remain in 2015 with a massive unmet clinical need for people who have dementia. Okay? We know that the care we provide people with dementia is not as good as it could or should be. Okay? We're fortunate to be living in a society where people are growing older. You know, with healthcare in midlife and early late life is to the extent that we're seeing people live well into their 80s, 90s, and even over the age of 100. But divide that by the lack of progress, in fact, the complete lack of progress, if you like, in therapeutic interventions for people with dementia. I often muse that when I worked here with David Ames, who many of you probably know, in one of the Cadams clinics in 1999 down in Frankston, just after the donepezil was launched, that the way I was working then as a psychiatrist and seeing people with mild Alzheimer's dementia, moderate Alzheimer's dementia, is no different, unfortunately, to how I went about my clinic last Wednesday in Edinburgh. There's no new diagnostic tests, there's no new drugs, there's not really anything happening in terms of other sort of psychosocial interventions. So despite the billions, perhaps even $1 trillion of investment in research that's taken place over the last, 15 years, it hasn't translated into any sort of net clinical benefit for people. Now, I'm slightly worried here because I've done 3 slides in about 10 minutes and I've got another 50 to go in the next 35. So Grant's probably going, how's he going to do this? Anyway, so we have a big problem. It's a very big problem. And everybody in this room will have seen statistics that have tried to articulate how big this problem is. But my favorite, if you like, is we're often comparing the challenge in front of us to be of the extent of trying to put a man on the moon. So Wikipedia is a marvelous thing. I managed to work out from Wikipedia what the budget for NASA was since its inception in 1958. And lo and behold, it's about the same as the annual cost of dementia, about 500 billion US dollars. So all the money that NASA has received since 1958 to put a man on the moon, to do the satellite programs, to do the space shuttle, is equivalent to 1 year of spending on dementia. It's a massive problem. So that's where we're at now. I'm an optimist. I'm a great optimist. And I think there is a way to map out a better future for people with dementia. And what I think is really important is we don't throw the baby out with the bathwater. Although what I'm going to talk about is prevention, EPAD, European Prevention of Alzheimer's Dementia Project, I don't want to get to a point with the excitement and interest in prevention that we forget about people with dementia, okay? So what I want to, just a couple of slides, is talk a bit about emphasis on care and prevention. Then I'll talk about some of these concepts about disease before dementia, much of which is, of course, predicated on the fantastic work that Colin and others in Melbourne have led through the ABLE project, the Australian Imaging, Biomarker and Lifestyle Project. But then we have to think about how we actually use data to reconceptualize brain failure, neurodegenerative diseases, and like I say, finish off with a consensus. So again, there's no data here, it's just a sort of context, a concept. Top panel is showing, if you like, where we're doing research, where the dollars are being spent currently in the research environment in dementia. And I don't know if this is the pointer, but there's a lot of money going into this condition called MCI, mild cognitive impairment, which actually doesn't exist. It's a description, it's not a diagnosis. But there's a huge amount of research going into this area. And I would argue, and I'd love to hear the clinical view in this, we're spending a lot of money in care for people with mild cognitive impairment, okay? And as a consequence, with a fixed budget, we've had to move a lot of the resources to these early diagnoses away from actually managing people with dementia. In the clinic I used to run in West London, we went from, because of the dementia strategy in the UK, which is all about early diagnosis, we went from 600 referrals a year to 2,000 referrals a year in 2 years. All of those referrals were coming in earlier in the course of the illness, their MMSEs were higher, but we weren't able to actually really do much with them other than say, come back in a year, we'll see what's happening. And what it meant was we had to close down our day centre, we had to take away money from the care packages to turn ourselves into a diagnostic factory. And I think that was a great shame. Where we should be is recognizing the burden of disease and the cost of disease falls within this zone here for people who've actually got dementia. And what we'd like to do is completely, I think, reframe this. Let's spend more money on care, and if we're going to spend more money in research, let's push it back earlier to prevention. So ultimately, we create by 2025 this new way of managing people or managing Alzheimer's disease, where we introduced at a public health or a primary care level true prevention strategies which we know to be accurate and effective. And we then have a knock-on effect of having a reduced incidence, so less people with dementia who still receive high-quality care. Why prevention? Well, the incidence of Alzheimer's dementia and all dementias, well, not all dementias, but most dementias, is a function of age, and every 5 years the incidence increases, it doubles. So the red curve is the current incidence by age band at the bottom. If we were to shift the curve by 5 years, then we'd get that sort of yellowy green curve. We'd actually reduce the numbers of people with dementia in the community at any one time. So this is, in some ways, the only way to manage this major healthcare burden, this major human burden, is prevention. I think nobody in medicine would disagree that prevention is better than cure. And in this space, I think prevention is going to be easier than cure too. Okay, so I think that's what we have to focus our attention on. You'll have seen a slide like this before, many in the room, but this is just the kind of the cartoon that Clifford Jack put forward a few years back, which we're now beginning to fill in the data, or filling in these curves with real data from studies like ADNI, Enable, and what have you. And what it's identifying is that the pathological processes which lead to dementia in later life probably have their genesis 20 or 30 years earlier. I say probably. EPAD's going to bring some really powerful data to really answer those questions. We also have this concept here of a kind of a cascade where A-beta, problems with metabolism of A-beta, the aggregation of A-beta, precedes problems with tau, which precedes brain structural changes through atrophy. But it's a very simplistic curve. Now, what we'd be wanting to do is identify where those arrows are at the bottom, accurately, people who are on that curve, well before dementia develops. Building up this biomarker profile that'll give us absolute confidence that individual is going to end up on a particular trajectory of illness. And I'll talk more about that later. We've also, I think, got a little bit stuck in a somewhat reductionist view of the brain, where we've tended to focus almost exclusively in two pathological processes. And by the time somebody gets dementia, if I go back, it's likely that the pathological processes are multiple and all important. And I'm not a pathologist, so Colin could probably add another 10 to that list, but there's at least 10 or 15 different pathological processes which will have an impact on the patient's clinical phenotype, how they present. Yes, there's amyloid, yes, there's tau. Cerebrovascular changes, how do we measure this? So if we treat people with an anti-amyloid therapy and we knock down that pathology, but do nothing for the other 12 pathologies, is it any wonder the drugs don't work? So what we have to do, conceptually, is be able to accommodate models of disease, or to be able to create models of the disease which accommodate all of these multiple pathological processes. And it's only by doing that that we can have interventions specific to that individual's particular profile, okay? It's what they do in oncology. You don't have a treatment for cancer, you have a treatment for a particular cell line or tissue type of a particular breast cancer, for instance. So that's what I think we need to be aiming towards in dementia. So this is my sort of simple cartoon. If you think about different pathological processes down that sort of left-hand column, in normal aging, you may well see the major driving force of cognitive decline that we see with aging is just the aging process, whatever that is, okay? But there will also be an accumulation of A beta. We see in the ABLE study, 30% of people who've got healthy cognitive function have got amyloid in their brain. So, what's going on there? But we also maybe see cerebrovascular disease, white matter disease. If you brain scanned every 80-year-old, you'd see white matter disease. So there are other things going on. Now, if you take somebody with Alzheimer's disease or dementia, their profile might look like this. And what we'd be looking to do is saying, well, look, when we do drug trials, as we've been doing over the last 15 years with very specific anti-amyloid therapies, we're doing it in that older population with all of those multiple pathologies still ongoing and unchecked. So what we need to do is be able to move the dial back and say, can we identify those individuals at the earlier stage of the genesis of the disease? And that's what we call secondary prevention. It's predicated on being able to identify these individuals before they develop dementia. Okay? So, secondary prevention, you have the disease, but you don't have the dementia. Okay? So primary prevention is you don't even get the disease. But in our case, we're working on the premise that you have the disease, but you don't have the clinical symptoms yet. So 3 things need to take place for secondary prevention. Number 1, you need to have accurate disease models. And those accurate disease models don't come about by people sitting around a table and going, you know what I think it might be? And they write it down and they publish these sort of consensus statements. I never get invited to those meetings, so that's why I'm probably better. But international working groups are usually a bunch of, usually almost exclusively men, by the way, who sit around a table and go, I think it must be this, and they put it down, and then it becomes something. We call it MCI due to AD at the moment. Anyway, so develop accurate disease models. Number 2, we need to be able to use those models to then stratify risk at an individual level and what their probability of decline is. And then, once we know what that is, we then identify precision interventions and also combinations of interventions that will affect the disease course. Now, this was the problem statement, if you like. How do we do this? Because this is a big ask. I mean, it's probably not a surprise to anybody in the room to ask these questions. They seem pretty straightforward, but to actually answer them is pretty challenging. Hence the reason for EPAD, which, if I haven't mentioned already, at this stage is 100 million Australian dollars of funding. And that's the scale of the project we're trying to address this. So, minions. The vision, if you like, is that any given individual from birth onwards can be given an accurate probability of a neurodegenerative event. Now, I've talked about multiple disease processes, but there's also multiple outcomes, so it gets even more complicated. We're not just talking about models that say plus or minus dementia. We can define our neurological or our outcomes by plus or minus dementia, 10% decline in a cognitive test, a 50% decrease in a biomarker change. That doesn't really matter, okay? But the models have to be accommodating of both multiple exposures or changes and multiple different outcomes. And that means we're making a prognosis, not a diagnosis, so that from this field of minions, we can recognize those individuals accurately who have a low probability of something happening from those who've got a moderate probability from those who've got a high probability, okay? And I say from birth onwards because I think, obviously age is a critical variable in this analysis, but it should be possible theoretically. Until recently, if you look at the diagnostic criteria for dementia, it was very one-dimensional, okay? I mean, let's assume that function is a consequence of poor cognition. So therefore, you're actually measuring, a later stage of cognitive impairment by saying they've got functional impairment. So we really only had one dimension by which we made a diagnosis. If they're cognitively impaired and they have functional impairment, then you have dementia, okay? And in this space, we had the concept of mild cognitive impairment, which was saying we've got a degree of cognitive impairment, but we don't have functional impairment. And we knew when we followed up these people that between sort of 2%, if you looked at a community sample, or 15%, if you looked at a clinical sample, would progress to dementia each year. So it's a very, if you like, your prediction was sort of, that if you're sitting in front of me with MCI, you've got a 1 in 6 chance in the next year of developing dementia. Well, thanks, doc, that's really exciting. But I'd like to know, is it 100% or is it 0%? So we need to work on that. So we added in a second dimension, which was biomarkers. But unfortunately, we took biomarkers that, if you like, are naturally distributed and turned them into a binary outcome. They're either biomarker positive or negative, and I think that's a little bit redundant intellectually as well, to be honest. So what we need to do, but it was an advancement. We've moved into 2 dimensions. We say there's a function and there's a biomarker, and that may increase your accuracy of prediction of what's going to happen to that individual. But despite what you might be told, these things are not 100% accurate. Okay, they're quite sensitive, but they're not very specific. So we need to move on from this a little bit. What we'd like to be able to do is say, if you measure these 2 dimensions, and there'll be a third dimension in a minute, by the way, if you measure these 2 dimensions accurately, you should be able to accurately predict what's going to happen over the course of time. And one of the challenges, I guess, we have is saying, well, can you actually predict just on the basis of a biomarker, i.e. before any clinical symptoms develop? And that would be really exciting. What we don't currently incorporate into our models of disease, and this is kind of the next step, are risk factors. So you've seen I've started seeing probability modeling rather than risk modeling, because risks are an exposure. So genetic risk, head injury, diabetes, these are risk factors. So what we need to do then is combine in this model these three different dimensions. And then what you get is quite sort of, any individual will have a probability in 3-dimensional space of something happening in the future. And this is a kind of the analysis plan, if you like, for what we're doing in EPAD. That's a higher risk individual, that's a lower risk, or higher probability individual, that's a lower probability individual. Next problem is that everything that we do has a confidence interval around it. And what we need to do is go away from the traditional statistical approach back to an even more traditional statistical approach invented by a chap from Edinburgh University called Thomas Bayes. And that's using Bayesian analysis to actually develop these models. And what Bayesian analysis simply does is, and I'm not a statistician, is it helps reduce the noise into a signal. It continues to evolve the model as new data is generated. So that you never actually get to a point where you make a conclusion. You get to a point. The way I think about it is like watching a horse race, where there's a probability at the start where every horse might win. But as they get nearer the finishing line, you get a more accurate assumption of what's going to happen because one horse is nearer the end than the other. And that's the same sort of concept. And you know that because time has passed and data is accumulated and you've got more and more evidence in front of you. And that's the approach that we'll be taking in EPAD. So you reduce down this wide confidence interval that you may have at the beginning of your modeling. So that individual occupies a very big, probability in 3-dimensional space. But by using Bayesian statistics, which we'll bring the data to through projects like EPAD, you actually reduce that down to a very narrow and hopefully very accurate prediction of what's going to happen to that individual. And then it's those individuals which you then target a particular intervention against. Is that all making sense, or do I have to do it all again? No? It's all good, okay? Fantastic. So, EPAD. How am I going for time, Grant? Because I have another 40 slides. Am I okay? Okay. Just pull me off. So, EPAD. So those were the sort of the basic observations about what we needed to do, and this was the basic approach of how we're going to do it. And it really did need these concepts to reach a consensus with various and very important stakeholders, the academics, the pharmaceutical industry, Alzheimer Europe, who support the project as well. We all came together in a kind of a beautiful harmony of understanding this was a big problem and we needed to do something about it, and we're absolutely committed now to doing something about it. So the EPAD mission, every good project has a mission statement. The EPAD mission is to create the pan-European EPAD machine that can deliver a standing, double-blind proof-of-concept trial for the secondary prevention of Alzheimer's dementia. So ultimately, we're about developing new drugs to prevent Alzheimer's dementia. To be able to do that, we have to create, and I'll go into this in a bit more detail, a very extensive, very large, very well-characterized cohort study. We have 8 work packages, which include, like I said, one about dissemination and engagement, public engagement led by Alzheimer Europe. We've also got a specific work package on ethics and legal and social implications, because of course what we're doing here is breaking new ground in some ways of risk disclosure and what have you. But like I say, we've got about 35 partners from across industry and academia working in probably about 20 very, very high qualified trial delivery centers in Europe. These are the partners, if you're interested. So we've got Quintiles as the CRO, we've got Alzheimer's Europe. You'll see many of the major universities in Europe involved in the project with all the sort of leading investigators. These are the drug companies who've committed to being part of the project, particularly highlight Janssen, who's the lead FPA partner. But it's only by bringing the public and the private sector together we can actually bring that knowledge and all the wealth of information that the pharmaceutical industry have and we have, bring it together under a single vision. Sponsored and managed by the mighty University of Edinburgh, which I'm delighted to say. All countries of Europe, west and north of Germany are involved. Like I said, 64 million euros of funding. That's just for the cohort study. That doesn't include the trial. The trial will be separately funded, so this will be well over 250 million by the end of the 5-year project. And we're partnering, we're talking actively to colleagues in the US, Canada, Japan, and Australia, okay? Because I think it sounds like a cliche, it's a global problem, it needs a global solution, it needs global partnerships. We can do a huge amount in Europe with tens of thousands of people we can involve in this, but Bayesian modeling, the more data you get, the more accurate the models. And I also think that the wealth of knowledge and insight and academia in and around Melbourne, particularly around the ABLE study, bringing that to bear on this project would just be absolutely fantastic. So I took about 10 hours to build this slide, so I like to leave it up for a few minutes. If you want to just copy it down, I'll just... So this is EPAD in a slide, all right? I don't have a laser pointer, I don't think, do I? Are they banned now? Everything else is. So essentially what we're doing in EPAD is we're taking what knowledge we know about disease models at the moment. Existing knowledge is helping us to build those disease models. And that existing knowledge is we have the ABLE database and we have the ADNI database. So the statistical engine room, work package 2, has really been sort of working very hard on that data to create our initial models, be they in genetics, epidemiology, imaging, biomarkers, etc. We've then just finished writing our cohort protocol. That's the 6,000 people at any one time who will be fully characterizing to provide people for the trial, but also data for the disease modeling. And that information always comes back round again. The data, the knowledge comes back round, is resynthesized, and it comes back to reinvent our models to optimize treatments. Okay, and that's just illustrated with this little moving. It'll probably move a lot slower than that. I mean, we're going to publish a new disease model every 6 months, just for information. So yeah. So another way of thinking about this is we're trying to move away from this concept of caseness. So at the moment, like I said, you obviously picked up, I'm not very fond of the term MCI, but we tend to stratify very complex phenotypes into buckets, because doctors like people being in diagnostic buckets, MCI due to AD, what have you. What we're trying to do is to break that down and, like I say, put every individual on a probability spectrum of disease. And that's why what I've tried to illustrate here is that the other thing I should add is that the only way we can do this is working with existing cohorts in Europe, so UK Biobank, Prevent, Generation Scotland, etc. We draw people from those cohorts because they have a particular profile. We then put them into our cohort study, and then we select people out. And we model their probabilities on their biomarkers, their degree of cognitive impairment, and risk factors. And those are the things that go into, so every individual will have a probability of decline, and we'll reinvent that every few months as the data flows. In the cohort itself, quite a traditional cohort, like at any one point in time, 6,000 people. As people leave the cohort, we'll bring new people in. It's essentially a readiness cohort, so when we do the drug trial, we know exactly the profile of that individual to bring them into the trial. One of the things that's bedeviled current clinical trials is the screen failure rate. People coming into the clinic and finding out they don't actually have the biomarker or the disease you're expecting them to have. We will know these people intimately and well. Is run-in data for the trial, which helps measure an effect against disease modeling and risk stratification. And we're planning annual follow-ups. We're going to do PET imaging, CSF markers, blood-based biomarkers, 2 hours of cognitive testing. It's a very comprehensive cohort. How am I doing for time? Because I haven't got a clue. Because I didn't. 15. Oh, 15. Oh, I can go slower. That's fine. Okay, so one of the ways, I think in some ways, because I've been living EPAD for the last 2 years, I get it, but it's sometimes hard to communicate it. So one of the ways I thought would be interesting to, or two of the ways to is interesting is, well, how does a subject move through the EPAD project to eventually being in the proof of concept trial? And the second illustration would be how would a drug. So if you had a drug and you thought, I'd like to play with EPAD, what would happen there? So let's start off with people. Let's imagine we're doing this in Australia, okay? And you're an individual who's actually in the ABLE cohort. And the ABLE cohort PIs have agreed to collaborate with the EPAD project. What we would do is we would put a data discovery software sort of program on the ABLE database. And we would search it for people who satisfied certain criteria. Are they ApoE positive? What's their age range? How much cognitive impairment do they have? And that system operates blindly to the investigators. The investigator doesn't know why a patient's maybe been selected for screening. So it's a virtual register. Then what would happen is EPAD Central would send the PI of ABLE a list of ID numbers that would correlate to the people who are in ABLE. And the cohort PI would then invite those individuals to come up to the trial delivery center and say, good news, you may be suitable for the EPAD project. Would you be happy to consent and to enroll into it? Once they're in the cohort, they're then potentially eligible to come into the clinical trial. And the clinical trial itself will have criteria specific to whichever drug's coming in. So some people might want to bring a drug for people who are at that higher end of the probability spectrum. Others may say, no, we want to go even earlier, and we want to look at people who are even earlier in the course. Or we may be able to do combination therapies. Okay. And once people complete the trial, they can come back into the cohort again. And all the data that we generate in the EPAD cohort can go back to the ABLE database, so they can have the advantage of that data for their own work. What about a drug? It doesn't have to be a drug. The EPAD machine could work for cognitive stimulation therapy. It could work for a lifestyle intervention. Okay, it doesn't have to be a drug. In the first instance, there will be drugs, but that's not to say they always have to be drugs. And the drugs can come from 3 sources. They can come from the pharmaceutical industry. They could come from an academic group who maybe got a spin out that's ready to go into a phase 2 trial. Or they may actually come from repurposing. So it might be, say, well, actually, we're really interested in looking at minocycline or indomethacin or something. If you can make the argument to the clinical candidate selection committee, that could be entered into the project. You'd also have to bring funding with that, because there's no funding in EPAD to actually run the trial. That has to be brought by whoever brings in the drug. The clinical candidate selection committee, which I co-chair with somebody called Andy Satlin, who's from ASI, with a body of other individuals, is really looking to see whether or not that drug is actually suitable for the EPAD machine. Is it ready for phase 2 testing? Has it got the sufficient safety data? Has it got all those other sort of criteria that would make it ready for phase 2? is the approach aligned to the EPAD master protocol? So the way we do the trial has to be really quite standardized because all the data gets merged into the same place. I should add that all the data from EPAD is open access, so the whole world can see it, and that includes the pharmaceutical company's data, which is a huge step forward. So all the drug trial data from Lilly and from Janssen will actually be in the public domain, okay? So people can really enjoy playing with it and coming up with their own ideas. That means we have to have a standard trial protocol. You can finesse it slightly if you've got particular safety problems with your drug, but essentially it's the same trial irrespective of the drug. One of the great things about this is we can also go back and do very quick feasibility. If you describe the patients you want, do they actually exist in our cohort? If they don't, then maybe we can't do it, or we have to prepare for it. If we know it's coming a year down the track, then we can prepare the cohort by going up to the parent cohort and bringing in the right individuals. And to do that, we're going to create what we call a virtual pipeline. So we will know at any point in time what's the next drug, what's the next trial, maybe a year or two in advance, so that we can then prepare the whole system for that drug coming in. We reckon this is going to reduce the cost of clinical trials by about 85%. Okay, because there'll be no screen failure, there'll be or very minimal screen failure, and it's just such a huge level of preparedness in the system. The proof of concept trial itself is in effect a two-step process. The ultimate aim is to take a drug that take a drug that works into phase 3 confirmatory trials. And one of the problems the pharmaceutical industry have is they don't kill drugs quickly enough. There's a point in time when they know that drug's not going to work, but they keep going with the trial because they don't unblind the data. In EPAD, you're always looking at the data, okay? Not the investigators, clearly they're still blinding, but there is somebody somewhere who runs what they call simulations, and if the drug is falling away and looking like it's never going to work, you stop the drug. So you stop exposing people to drugs that will never see the light of day, and that's an adaptive trial design. And there's two steps. Number one, you predefine what you'd like to see in terms of your biomarker outcome, a reduction in A beta or tau, a reduction in tau or A beta. If it makes that first target, then it graduates into looking at its effect against a cognitive outcome. And if that makes it, then it'll roll into phase 3 trials. So again, in order to advance the candidates most effectively, it uses this Bayesian adaptive design. It's always learning from the accruing data as the trial progresses. You don't just, as you know, people who do trials, you start a trial, you wait 5 years, you get your result, you go, it didn't work, which is always what we do, unfortunately, these days. In this case, you say, we start the trial, we look at the data in a week, we look at the data in 2 weeks, we look at the data in 3 weeks. If it's never going to work, because you've got all these in your simulations, you say, let's kill it, okay? So people may come into a trial which finishes very, very quickly because there's no chance it's ever going to work, okay? Very efficient once you've got the machine built. Very inefficient if you try to just do that once with one drug. Like I say, planned discontinuation of additional enrollment once such a signal is detected. So it's also, if it's looking good, okay, then you move into phase 3 early, okay? So you can kill drugs early, but you can also graduate them early. So just to conclude, EPAD, the European Prevention of Alzheimer's Dementia project, represents a leading part of a global initiative to deliver an innovative, I can never say that word, trial design for the secondary prevention of Alzheimer's dementia. And the key advantages of EPAD is its comprehensive nature and its coordination within the same platform. Access to parent cohorts, so we can manage who comes into the project on the needs of the project. Very explicit and actually public clinical candidate selection process, so we know which trials we're going to be doing. The cohort study, which will help with disease modeling that I dwelt on a little bit earlier. Unified data management system, there's one data system, all the data goes into a single repository for all these analyses. And like I say, one of the other key advantages I think is that we're actually now sensibly and maturely looking at public-private partnerships. We're really bringing the wealth of knowledge and resources from the private sector, matching it with what's in the public sector to really sort of fulfill the vision, the aims of EPAD. Hasn't come across very well. Must be something to do with Apple onto PC. But I actually found a map before I came here, if you notice, where Australia's right in the middle. So I thought you might like. I shouldn't have highlighted that. I should just let you subliminally pick that one up. So Scotland's just stuck off the edge now. But anyway, so what this says in behind all that sort of reformatting that PC has done is USA, Canada, they put a grant application literally in today to their government for, I think, about 15 million Canadian dollars. The US have managed, the investigators there have managed to convince the NIA, and they're putting in a grant for 25 million US dollars. We've spoken to investigators in Japan who are taking it upstairs to their government to see if they would be able to invest. And obviously Australia, it would be great if we can work out a mechanism to collaborate this project here in Australia. These are the folk, the leads, if you like, in EPAD, just for you know, to acknowledge the number of people, the wealth of people who are involved across the various work packages from both the pharmaceutical and academic space. And just to conclude, how do we achieve prevention? Well, I think we have the means, we will have the means to identify people accurately for secondary prevention. Through projects like EPAD, we will then be able to develop those interventions of proven effectiveness. But how do we find the people, the benefits, so we can reduce incidence of dementia? My horror is that we do all this fantastic work, we do all the science, we do all the experimentation, we produce the intervention, and it takes 20 years for clinical services and governments to say, oh, right, how do we find these people? Because they're, by definition, they're asymptomatic. They're people in this room, okay? They're not presenting to memory clinics. So we have to think concurrently with a mechanism to identify people. So the public, because the public are very involved in EPAD, they're part of our thinking. They're driving this whole thing forward with their wish to have dementia prevented. So the public, researchers, and industry may deliver this roadmap, but ultimately it's governments, the food and leisure industry, risk modification, sugar tax, the food and leisure industry, public health, and primary care that must use this map. And it's only really through working together will we achieve success. And it's that working together, which I think is beautifully illustrated last weekend. So I'm going to stop there with that beautiful image of England getting beaten at rugby and invite any questions, or we're going to leave that to the panel. Now, I was actually predicting someone was going to shout out, yeah, but we're going to beat Scotland at the weekend. So I had myself all ready. This weekend, can a small country beat a sports-mad big one? Yes. Yes. How? And there's a great example for you. Okay, so thank you very much.
I'm just going to move that one on. Thanks, Craig. Thanks very much. Were there any questions specifically about the presentation? Noel.
Yeah, changes. This might be a bit detailed, but and I'm sure they're involved in the partners you had. Excellent talk, great opportunity. In Australian context, it's a bit like a global CRC anyway, isn't it? But the question is, where do the regulators sit in this? And how does it fit in with NDA and endpoint analysis and things for phase?
So we have a regulatory working group, which is in very close and intimate contact with the EMA. And the FDA are looking at all of our output. So we're in a dialogue. We're actually going for formal scientific advice in January, and we're preparing, all this is turning into a briefing document with scientific advice being sought. So this is publicly funded at the end of the day, and then it brings in industry partnerships. And I think what we've done is we've recognized exactly what you say. There's no point creating this in isolation of the regulators. They have to accept a preclinical population as a target population. They have to accept our disease modeling work. So we are in dialogue with the regulators all the way through this. Yeah, absolutely. Yeah. Now, I used to do ward rounds with Dr. McFarlane down here, and I was just thinking that he was always the worst person in the world to ask questions, because we used to sit in ward rounds, he used to ask these questions, and I never knew the answer, because they were so insightful and so clever. And then Steve puts up his hand, and I go, oh God, what's this going to be? So,
What you're doing, it seems like, is identifying a way for drug companies to conduct clinical trials ultimately very efficiently,
Yes.
very cheaply.
Yeah.
Is there a danger that unless countries like Australia come on board with this initiative, that we'll effectively find ourselves locked out of the clinical trials market? Because if we can't access Australian patients for trials through a similar registry, Janssen and Lilly aren't going to come and do their trials in Australia.
I would hope not. The reason I say that with confidence is because we're not in an environment for doing phase 3 trials. So you've got to ask the question why you want to do clinical trials with commercial companies. And I think there's obviously very good reasons for doing that, including access to new treatments, etc. But the phase 3 space will still be benefiting from this. Yeah, sure. Personally, I would love it if Australia was involved, without a shadow of a doubt. And then the Australian community, be it the public, the academics, the hospitals, get access to phase 2 trials. I don't think we're going to monopolise this space in the next 5 or 10 years. I think it's going to have to prove itself. But there's still going to be plenty of work going about. But yeah, but it's a good question.
Craig, can you just really quickly explain what a phase 3 trial is
Sure.
versus 2 and 1?
Yeah. So phase 1 is first time in human. So you take a drug and you go into a healthy volunteer population, 21-year-olds. In the UK, they're usually Australians and South Africans who are traveling to get a bit of money. So that's a phase 1 trial to check the safety, the pharmacokinetics, how the drug moves around the body, etc. Phase 2 is a learning space where you actually learn about your drug, you learn about the population that maybe benefit from it best, you learn about the best outcomes. And once you've learned enough about it, you then move into phase 3 confirmatory trials. One of the problems, if I can go off piste a wee bit, is that people were jumping from phase 2 too quickly into phase 3 because of the dollar signs that they thought, well, we must be first to market. And they weren't spending enough time learning about their drug. And that's what we're trying to do now in EPAD.
Great.
Okay.
Thank you. I'm going to plonk yourself here. Thanks very much. That was a great talk. And the slides were beautifully done.
Thank you.
I'm really honoured to be invited to do this and also to be part of the Wicking Trust panel. And they treat me a little bit like the canary in the coal mine because if I understand it, that means everybody else will. So, excuse me, my questions are going to be a little bit more general because I thought this was a great opportunity. And I just wanted to also introduce Maree McCabe. Some of you will know Maree, who's the CEO of Alzheimer's Australia, Victoria. And Maree's background is as a senior executive across mental health and aged care sectors. And Colin Masters is Senior Deputy Director of the Florey Institute and Laureate Professor at University of Melbourne. He's also with me on the panel. So I'm going to ask some questions, but if you wish to jump in and join the conversation, please do. There are microphones, 2 microphones. 1, sorry, and Grant has it. First question is, how do you pull together such a huge project with so many different organisations and people all working together? We had this conversation today about a multidisciplinary project and how hard that must be.
It's a shared vision, really. I think we'd got to a point with the number of drug failures, with the evidence that was coming out from preclinical studies like ABLE and ADNI, that we had a very clear vision of what we needed to do. And when you spoke to people, be they the academics or the pharmaceutical industry, they agreed. And when the call went out, it wasn't hard to motivate people to want to be part of it. Then there's a bit of arm twisting and a bit of cajoling to get people into your team. And we did that quite effectively. So there's only actually one application that went in against this grant. But I think it was just making very clear what the task in hand was, and people agreed with it. So and that's still the kind of the glue that binds the whole project together.
So I want to say a few words, but I just want to get in at the beginning. Here's a man who not only talks the talk, but walks the walk, and I'm very pleased to say that we educated him in Melbourne 7-8 years ago. We spent 4 years, we sent him back to the UK, and he really learnt a few lessons. And the answer to your question is, he watched very carefully what we did with ABLE, and we kept it relatively simple. We had 2 sites, Perth and Melbourne, and we asked very focused questions. But it was all around, how do we address this question of eventually understanding the natural history of Alzheimer's disease, and how can we intervene at the earliest possible stage. Now, they've been watching us, and they've taken to heart what we've discovered, not only us, of course, but other people in the world, the US group. But there's been absolutely a revolution in the field over the last 5 years. And so we now feel very confident that we can identify preclinical and prodromal Alzheimer's disease. I agree with you, we should get rid of the term MCI, so it's preclinical prodromal disease, and that is where we're going to intervene. And I think that Craig has actually put so much intellectual thought into this process. He's come up with what I think is the world's best model of how we can work together as a community to address this question. Everybody talks about prevention of dementia, prevention of Alzheimer's disease, but that's talk. Nobody does the walking, and this is the walking right here. You must get these cohorts together. They must be of sufficient clinical size and critical mass to be able to begin to address these fundamental questions as to how we get a drug in. And the critical thing that he's discovered, and we've known it for a long time, but he's putting it into practice, is it must be an adaptive design. In other words, you put the drug in and you see what happens in real time. And we can, for the first time now, monitor reductions in amyloid or tau or any biomarker. We can actually do it in real time as the drug is being administered. But to protect what do we call it, the hiddenness of whether the placebo effect and the active, only certain individuals are allowed to know and look at the data as it's being applied in real time. And what he's put together here is so interesting, and I think this is the answer to your question, is so interesting and so self-evident that all the researchers in the Europe and now the US and now Canada and we in Australia, we can see that this is the way to go forward. And so there's no hesitation on our part to say this is where we need to be over the next 5 years if we're serious about preventing, delaying onset of Alzheimer's disease.
That was my next question, actually. Is it preventing it entirely, or is it delaying the onset that is the real goal?
Craig? Well, the goal from this is to prevent dementia, and I think, I think age is a critical risk factor. We can't do anything about aging. I think what we would be seeking to do, as my sort of early slide suggested, is if we can delay the onset by 5 years, then I think it's a massive step forward to where we are currently.
You have to walk before you run. So first we learn how to delay it, and then we can
we'll prevent
learn how to put it off for a long, long time.
Oh, yes?
I was going to question whether you think,
wait for the microphone.
Whether you think there's, Colin talks about pharmacological interventions. Do you think there's any potential for real-time benefit? We know there is some kind of longitudinal benefit, but real-time benefit for lifestyle interventions?
Yeah. So the eagle-eyed would have noticed that one of my key collaborators is Maree McCabe, who's just obviously recently published the FINGER study, which hasn't got a drug in it, but yet they've delayed cognitive decline in at-risk people over the age of 67. So like I said, this model will fit drugs. It's been designed with drugs in mind, but it has been also future-proofed to be able to accommodate other interventions. And I think at the end of the day, and it's not a slide I took out of my deck, but if one talks about treating cancer, lung cancer, you may have specific interventions, but you get them to stop smoking as well, don't you? So I think what we need to do is also do the risk factor, modify the risks that we can modify, and also on top of that, it's never going to be one silver bullet. It's going to be a combination of pharmacological, lifestyle, maybe psychological interventions that will come together to
So we have to give a plug for Australian entrepreneurship. We've done this already with Nicola Lautenschlager in a small project that many of you don't know about, but it's called Able Active. So what she's taken, and Bryony, you know this very well because she's closely affiliated with NARI, she's taken a subset of the able people and explored in this subset whether physical exercise can have an effect on the rate of developing cognitive impairment. Now, this has been a double-blind study.
Yeah.
It's only recently closed. It's been done in the old-fashioned way of, you start, you end, you analyse the results at the very end, and then you say it works or it doesn't work. Now, what we are talking about now is a new model for looking at interventions, and these interventions could be of any sort.
Did you want to jump
Yeah,
in?
I actually did. Craig, I was interested if you'd taken into account the work of Christine Yaffe that Christine had done in the US in terms of prevention. And we know that if we could delay the onset by just 5 years, we would reduce the numbers of people who get dementia by 30%. Yeah. So you would die healthier. So it's a significant, that's a significant a number.
Yeah, and I think so when we, yes, we have, and also the work of my namesake, Karen Ritchie, who produced a very similar paper from the 3C study. So I think, and Yaffe's not part of our group, but she's part of our scientific advisory board, as is Colin actually. And that's why in the cohort study we are measuring all those potentially modifiable risk factors. So we're looking at lifestyle, exercise, because in the model, then we can measure what impact they have, poor diet or being overweight, has on progression. And we may well find that modifying modifiable risk factors has as much impact on outcome as a drug in certain individuals. Yeah. So these are all things that are going into the mix, absolutely.
As an interested observer of all of the work that you all do, there seems to be a headline every day with some kind of result from research. It's incredibly confusing, I think. One doesn't know what to do. I mean, I don't really want to have to learn how to do Sudoku, for example. But is there too much headline chasing in this sort of whole area of research into Alzheimer's?
Unless there are headlines, yeah. I think we all get headline fatigue, don't we?
Hard up getting them from the age.
And Amanda, I'd certainly like to comment on that. I mean, some of the headlines are very distressing to people living with dementia and their families and carers. They think that there is a cure that's available for them that's not. And in fact, many of these headlines are years away from being able to be trialled with humans, and I think that what we want to give people is hope, but we don't want to give people false hope.
Absolutely.
So I don't know how you deal with this issue, because it's not just in the dementia space, it's right across the whole medical research space. And we're in a self-fulfilling prophecy type arrangement where if you don't get your message out, you will lose the objective. So I don't know what the answer is, but we have to play the game. So there has to be a balance here. And when I say playing game, I don't mean that people are going out and deliberately making false claims, but their claims are clearly over-exaggerated in many examples. And I always, when I'm talking to the press, I try and never use the cure word, never use the breakthrough word, never ever, try and say that, it's a breakthrough. But they go away and the sub-editors will put breakthrough into the headlines. So you've got to live with that. I don't know how to manage it.
Well, as someone who used to manage editors, it's very difficult, I can tell you. Question?
I've been in both the studies, and I've completed the physical activity, able activity program, and I've moved on, and luckily I was in the control group, so I didn't have to do too much, if you know what I mean. But going back to the ABLE study, initially it seems to have had numerous MRIs, numerous computer topographies, numerous psychological tests, and early days trying to identify a better biomarker for the amyloid protein, and now you seem to have moved on to tau, and I begin to wonder, although I did sit in with a program over at the Royal Melbourne Hospital where the coordinator of the program explained what the central hypotheses were for the study. There are two questions. Is there such a thing as a central hypothesis? And secondly, in terms of the global nature of the study, and I'm not too sure which other countries are involved, are you doing exactly the same thing? And is it going to be terminal, or is it till death do us die?
Well, ABLE is an observational study. In other words, we take volunteers like yourself and we invite you to come in and be observed over a long period of time. Subsets we invite to intervene but just simply by observing you over a long period of time, and Abel's now gone on for 6 or 7 years now, we are getting a very, very accurate idea of rates of change. Everything depends upon the kinetics of rates of change, and we are measuring that. Every time you come in and you do a neuropsychometric test, it goes into the data bank, and we compare your test with everyone else over a period of time. And we're beginning to correlate these things with different genetic markers, lifestyle interventions, and so on. So the hypothesis comes when we start to interrogate the data. We did not have any fundamental preconceptions as to what we were looking for at the very beginning. We said we're just going to look at a large population over a long period of time. But we knew that some of these imaging techniques that we are using, and which Craig and others are now implementing, have the potential to unlock the secrets of how this process evolves. And that presupposition has come to fruition, because we now know that we can do a PET scan, or we can do a lumbar puncture and measure certain variables that give us very accurate ideas to what's going on. But as Craig was pointing out, we now need to go to the next level, which is bringing back all of these risk factors and address it to the individual. And we haven't quite figured out yet how to do that. And it's a complicated issue. And in Craig's presentation, he talked, I loved the way he put it up, 1 dimension, 2 dimension, 3 dimensions. There may even be a 4th dimension as far as
time,
something like that.
Change
over time. And we have all the computing power, the informatics power to pull all this together now, but we still are missing a few key factors. And one of these key factors that we're missing, we were talking about it today, is what is the contribution of cardiovascular disease to the process that's going on in your brain as you get older. And we're only at the very beginning now of being able to address that technically, because currently our imaging techniques are not sufficiently good enough to pick up very, very small, what we call micro hemorrhages, micro infarcts in the brain, less than 1 millimeter in size, often caused by an irregular heartbeat that throws off an embolus up into the brain. So we haven't figured out how to take that into our risk calculations yet, but we will. Over the next few years, we will begin to unravel that, and I predict that as EPAD rolls out, we'll become super specialists in making predictive algorithms for individuals.
Question down there.
Can I just quickly say, though, when I was presenting, and I said in our original disease models, we threw in all the ABLE data. Thank you. Because that data comes from your time and effort of going up and having all these assessments done. We would not be anywhere if it hadn't been for the commitments and the partnership that we have from people like you. So thank you so much.
That was a brilliant, illuminating answer.
Okay. We could just go on and compliment each other if you want for the next half hour, but truly thank you.
I think we'll take the next question.
Thank you for a fantastic talk. My question is about the way you're analysing your data, and I understand the appeal of the Bayesian statistical analysis, and it's obviously going to fast-track some of those studies. I'm presuming, though, that although the biomarkers are so very rich in analysing what happens to those is fascinating, the clinical data is going to be far more important to people. And so analysing the effect on clinical decline is going to be more important. You're still going to need a number of cycles of data collection. So are the studies really still going to be that much faster? Because you still need 2 or 3 at least data collections, I would assume. Sure,
that's a really very, 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 very good point. Are you a neuropsychologist or a statistician? Okay, very insightful. No, because we would love to make that cycle as rapid as possible by doing 3 monthly or 6 weekly cognitive assessments, but cost and burden just preclude us from being able to do that. So the original, the protocol states we're going to do it baseline 6 months and then 12 months and then annually thereafter. So you're absolutely right, you can only model the rate on the data that you've got coming into the model. I mean, you can do some imputation between the time points. But that's why in some ways that little Bayesian noise to signal is going to be improved over time, because that frequency isn't going to be as critical. I mean, you can measure the slope in between, so there will be that. But no, you're absolutely right. What I should say is that one of our we've got 4 scientific advisory groups, and probably the most challenging has been the scientific advisory group on the cognitive outcome measure, because the temptation, dare I say, particularly from industry, was to drop in very familiar measures. But what we said was, well, actually, those measures are good for dementia trials, but they're not good for necessarily preclinical trials. So the group's chaired by Karen Ritchie from Tasmania, no relation, who's now working in France, and they've taken it from the brain forwards rather than from dementia backwards. So a lot of the measures we're doing are very, I can't say innovative, but they're actually premised on hippocampal atrophy, mesial temporal lobe changes. So it's been probably one of the most challenging things. And to come back to the question, we've got to convince the regulators that these measures are actually picking up what we want them to pick up. So it's been a huge challenge.
One more down here.
Could I ask the panel the concerns that are emerging following surgery, or particularly anaesthesia, with cognitive deterioration, and particularly repeated anaesthesia?
Yeah, well, and Wayne, as you know, that's an area that we've been working with Brendan Silbert at St Vincent's on. So there is this condition called post-operative cognitive impairment, cognitive decline. Nobody really understands whether it's a vascular phenomenon or whether it's because of underlying Alzheimer's disease of prodromal preclinical nature. But the phenomenon clearly exists. You have a general anesthetic for a bypass surgery or hip replacement or something like that. You come out of the anesthetic and you're clearly more cognitively impaired than when you went into the anesthetic. So it's a big issue. And it needs more research. But we now have the tools to be able to really dissect that in much more accurate detail. But we don't have the answer yet. At least I don't have the answer.
I just drop in. I actually examined a PhD last week who's looking at the HPA axis and POCD, and able in Edinburgh to actually take CSF samples off of spinal anesthesia. And one of the things that we talked about after the Viva was creating an EPAD-like machine for POCD. So actually, because I know they're collaborating with people in Sydney and I think in Melbourne and Oslo, to actually create this environment to really try and understand more about the disease processes within POCD and postoperative delirium. So taking that model and applying it into another disease area, very similar disease area, would be hugely helpful.
I wanted to just bring it back a little bit to the area of care. So if it's going to take many, many years before you do prevent Alzheimer's, we have a big caring issue, both people who are the carers and those who need to be cared. What are the tensions there between research and this sort of medical area and the caring area? Maree?
Well, there certainly is a tension, Amanda, and I mean, the research is absolutely critical, and so is caring for the numbers of people globally that we have. And right now in Australia, we have around 1.2 million people who are caring for people living with dementia. Now, the Caring Places report that was released in 2012 showed that by 2050, we are going to be short 120,000 residential aged care places and 150,000 paid and unpaid carers. So there is a massive pressure on the community to look at ways in which we can ensure that people are cared for. And the other thing is that many of our clients living with dementia want to participate in research studies, and many of them are in fact participating in the ABLE study because they see it as their way of giving back. And for many of them, they realise that it's not something that will benefit them, but may benefit their children and grandchildren. And whilst there's a tension, there's also a synergy. And it's certainly something that Alzheimer's Australia encourages, is that our clients do participate in research studies, and we have a very massive pressure on ensuring that care right now is appropriate to people's needs and delivered in environments of their choice.
Colin, do you have
Maree's the expert here. I always defer to the experts, but you're a practicing physician. I'm a ivory tower researcher. Craig, what do you think?
Well, I mentioned babies in bathwater. I mean, I think the research has to go earlier in the course of disease, as we've talked about. But I think, you know, I took issue with the amount of time, and I'd love to know what it's like in Australia, of the resources going towards MCI in clinics, because there's not a huge economic burden, probably not even a huge. They're inquisitive about what's happening to them rather than actually suffering from dementia. And I think we have to rebalance this and put much more of our social care budget and our healthcare budget into people who've actually got dementia. Because we've found that we've had to move all of that money into diagnostic factories, and I think people are suffering as a consequence.
Yeah. Very interesting point. Ashley had a question down here.
Can I ask
Wait for the mic. Thanks.
I just wanted to clarify something. This is fundamentally a secondary prevention project, correct?
Yeah.
So you are going to try to capture what you call the parent cohort of individuals where there's the presence of the disease.
Yeah.
So a couple of questions. What do you do with the people where you think they're completely well? That's question number one. Question number two is, how do you define the presence of the disease? So you mentioned that you can get quite messy brain pathology as you get older, and we perhaps have been a little bit too exclusive about our definition about what might be Alzheimer's disease. So I'm just wondering how you deal with these two matters.
We don't describe. This is one of the things I've really got to fight against within the group. Is we don't define presence of disease on a threshold of positive or negative, number one. So to do our disease modelling, we need people across the range of disease pathology, from absent to SUVR of 3.7. So we need to bring as many people in as we can. The way we identify them in the parent cohorts, like I mentioned, we have this what we call a patient discovery tool, which we can run an algorithm on. So we can set the dial to say we want people who are this age range, who've had this amount of cognitive decline, who've maybe got an ApoE that we know about. But you're only as good as the data that's in the parent cohort, okay? And we've also got the issue about disclosure of risk, because a lot of the parent cohorts will not have disclosed their amyloid status to them. So we're blinded to that. Once they come in and get baselined, then we will look at the aggregated data to see if we are maintaining that balance. And we've got 3 ways of actually being able to do that, which are quite complicated. We can undersample or oversample for particular parent cohorts. We can change the algorithm, or we can actually deselect patients at their 6-month visit. So if they're not going to contribute to the disease modelling or to the trial, we can actually bring them out of the cohort. I'm not sure if that answered the question, but
if they're completely well?
We will need some people. We will need some people who are completely well for our modelling work. But I don't call them controls. People say you need control. It's not a control group. Because, of course, the other thing is they may be completely well now, but EPAD's going to run forever. In 10 years, they may not be completely well. And that individual who's been well at baseline with no evidence of disease, who then progresses, they're incredibly valuable to the project. So, you know, everyone's valuable. That's why there's overage. That's why there's like 6,000 people in the cohort to get 1,500 in a trial. Because if we just were going one-to-one, we would just be doing a trial. But the cohort.
So we have these people in ABLE right now who are well. And they're so well that we call them supernormals.
Yeah.
But we don't tell them that they're supernormal because we don't communicate. You, sir, could be a supernormal person.
Obviously.
You know, no changes in their brain, perfect mentation, all that sort of. But they're absolutely essential for our studies because we're learning for the first time, and this may seem an outrageous statement, that if you are perfectly well, you do not decline in your cognition over 5 or 10 years. The brain does not age in the horizon that we're talking about. And that is going completely against what a lot of people commonly believe.
So I work in Edinburgh with a guy called Ian Deary, who works in a centre for cognitive ageing and clinical epidemiology. And all his work is about resilience, and all my work is about risk. And it's 2 sides of the same coin. You know, what are the resilience factors? And we want to have that data as well. So we want the supernormal in our cohort so we can actually model out resilience as well as we can model out probability of decline. Because if we can enhance what makes you resilient, that's an even better intervention. So the more data we get, the better.
Question there?
Yeah, just one more question. Given the amazing increase in lifespan that's currently happening per annum, in other words, how long everybody lives for, is 5 years bold enough? I mean, by the time you've done, 15 years' time, you've got an answer, the 5 years won't be relevant anymore. You're going to need 8 or 9 years.
The EPAD 5 years?
Yeah, so by bringing the
delaying
the onset by 5 years.
No, that's just the first step.
That's the first step.
Yeah.
It'll be
But
forever
I just
one
wanted
day.
to start with right now, is it bold enough? Because the time it's going to take to get there is
You don't
5
know how
years.
to
Is not
delay
going
it by 1 year yet. I mean, that's a 5-year delay would be fantastic.
Just a question about, I'd like to be bold, and I think that there's an opportunity here to be more bold than 5 years.
Thank you.
I wanted to ask, are there tensions, because we're here for the Wicking Trust, which funds research, are there tensions between funding research that looks for a cure as opposed to a means of prevention? Is there a holy grail that we should just say, okay, everyone's going to start working towards prevention, that's it, don't do anything else, it's the most important thing?
Well, I hate the C word because it's unrealistic to expect someone who has dementia to be cured. I mean, that's got a very, my wife's an infectious disease consultant. She does cure people. You give an antibiotic and they get better. They're 100% improved. They're back to a full state of health. Do we really think that people with dementia who've got end-stage brain failure can be given any sort of intervention where one day they'll start driving again? I think it's ridiculous. I think it's ridiculous to promote that as a possibility.
But in the early stages, I still think there's enough, we know enough about the mechanisms of Alzheimer's to think that if we totally remove the insult in the brain, that is the amyloid or the tau, that there's a good prospect that we could at least stabilize, if not regain some. Now, that's
not a cure.
Well, it's not a cure. Complete reversal from the moderate to severe stages is, with our current knowledge, I don't want to be totally nihilistic, but it is asking too much. Right now, the best thing we can ask is to slow it down and delay onset. That's the most rational thing that we as human beings can do right now.
There is an intermediary step, Amanda, and that is about restorative care and improving the quality of life for people that have dementia and ensuring that they live the most positive life that they possibly can. And there is a midpoint about that. So the cure bit, absolutely. We can't cure what people already have, but we can improve their quality of life. And we know that lifestyle factors can actually improve dementia even in its moderate to more severe stages. So
do you think there's enough focus on that, Maree?
No, I don't. I think that there is I'm concerned that there is an attitude that once people have dementia that there is nothing that can be done, and there's a lot that can be done. And that's what we want to promote, is that when people get dementia, it's not necessarily, it is a death sentence in terms that it's the second leading cause of death in Australia, but there's a lot that can be done to enhance people's quality of life. And using the principles of Montessori and the age-smart principles of Professor Karashima in Japan, there is a lot that can be done that makes a very profound difference to people's lives.
Why isn't it being done?
Well, in some pockets it is, and it's really it's one of the challenges that I think the residential aged care sector faces in balancing compliance with innovation. And innovation is often thwarted in the sector because it's so compliance focused. And so, there are many organisations that are doing some great things, and they really need to be expanded and elevated such that it's happening everywhere, not just in discrete pockets.
I have a question here which Colin actually suggested I ask. I like it so much I will, which is,
do you have the answer?
You've been funding research into Alzheimer's for such a long time now without really getting the result. Why do we keep funding it?
Well, since I put the question to
You've obviously got an answer for it.
It's called a Dorothy Dixer, I think. Did he have the answer?
Sorry.
I just asked, do you have the answer?
The explanation that I have, and you may or may not agree, is that we're facing a challenge like cancer, and incremental progress has been made in treating cancers and preventing cancers over the last 30, 50 years. The same thing is happening now in dementia and Alzheimer's disease as we learn more about it. So I'm totally optimistic that we're beginning to see some efficacy from some of the clinical studies that are going on. There may be behavioural interventions or they may be drug-related interventions, but we're beginning to see the light. And can we end up on a plug for the A4 study? So we are trialling a drug made by Lilly, a drug called solanezumab, in people who have preclinical disease. In other words, they're totally normal, aged about 75, but they're coming in and they're going to work with us for 3 years, and we're going to see if this drug, which has been shown to have a 30% slowing of cognitive decline in the milder AD group. So that's what I mean by a glimmer of hope. So for the first time, I believe we're beginning to see some efficacy, whereas a few years ago, I'd have to admit that we have nothing, well, apart from your behavioural interventions, we have nothing to offer in a mechanistic sense.
Maree?
Yeah, it's a tricky one, and it's interesting because when you were talking about solanezumab, I was thinking about Aricept, and there was a recent move to have it taken off the PBS and only used in the early stages of dementia. But what our clients were telling us, that even though they'd been on it for a long time and they were not seeing the improvements in executive functioning anymore, what it did do was remove the fog. And we lobbied very hard to keep it on the PBS so that it did actually make a difference to the quality of life for people living with dementia. So I think, yeah, I agree with Colin.
But there's not a clear cut. But
No,
Craig, what's your view?
clear cut.
Why should we keep funding this research?
Because we need to.
And if we'd given up on cancer 40 years ago, we wouldn't be where we are now.
We just can't
and
give
heart
up at
disease,
this stage.
yeah.
You know, we look at the statistics, we look at the human suffering, and you know, it's upon us to do something about it. And the only way we're going to do anything about it is through research. Colin's right. It's a slow, it's maybe even a glacial process. But I mean, I said, of course, that 1999 and last week I was doing the same thing in clinic, which is true. But that's a question about research into practice, rather than necessarily the research not showing benefit. But it's often very hard to get the findings from results into clinical practice. That's usually finance and awareness more than anything else. But look, research is, you know, standing on the shoulders of giants. If the ABLE study hadn't happened, we wouldn't be doing EPAD. And that's how we progress things. It might not be tangible yet, but we expect it will be, you know, over time.
And given the global health crisis that dementia is, Amanda, it's really important that we continue to fund research to either delay, prevent, treat or cure.
But what we shouldn't do is research for the sake of research.
Yeah.
We need to talk to the people that matters to most and ask them what sort of research should we be doing. Should it be prevention research? Should it be behaviour? You know, and I think that sometimes we do research for our own sort of inquisitiveness rather than necessarily to make a difference. And I think we need to start developing partnerships with the public and with patient groups to actually understand what exactly we should be doing research on and using our resources and skills.
It's a novel idea to ask the public what they'd like to see research.
It's called PPI. Do you not have PPI in this country?
Very, very open to consumer input into
Yeah.
what matters.
Yeah.
Yeah, okay. Any other questions?
I think it's time to
Is it time?
socialise, Grant.
Okay, well that's terrific. Thank you very
Thank you,
much.
Amanda.
And it was a good discussion.
Thank you, Amanda, Craig, Maree, and Colin. Thank you very much for, firstly, a very stimulating presentation and a great discussion from the questions, I gather we've got quite a diverse audience here. We've got hardcore researchers, we've got people who have been touched by dementia in some way, we have academics, we have, you know, people from every facet of life looking at this differently, and I hope you agree with me. From my perspective, we got a great discussion that actually gave something to all of us and made this comprehensible, despite that one slide.
The tennis.
No, not the tennis. The one slide explaining EPAD.
Oh, that one.
Yeah,
I thought you meant tennis.
But thank you very much for giving up your time. Craig, it's been great to have you here. Could I ask you to one more time say thank you? Finally, if I can just reiterate Tabitha's words from earlier, it really is a great privilege for us to be involved as equity trustees with the Wicking Trust, and we look forward to seeing you at another one of these in the future. So thank you.